There is no specific requirement in the National Electrical Code, or NEC, that outright bans the use of one-hole straps for supporting exterior electrical metallic tubing, or EMT. However, the NEC contains general guidelines applicable to all electrical installations, including those using EMT. A core principle is that all electrical equipment and materials must be installed in a way that minimizes the risk of corrosion. Therefore, if one-hole straps are used to support exterior EMT, they should be constructed from a corrosion-resistant material such as stainless steel or aluminum, or otherwise protective from the elements with a coating or paint designed to prevent rust and corrosion. Proper installation is also crucial. One-hole strap should be installed in a way that prevents water from accumulating inside the strap itself. This can be achieved by using a sealant around the strap where it contacts the EMT or the mounting surface, creating a watertight barrier. Alternatively, installing the strap in a downward-facing position, with the opening facing down, can help prevent water from collecting within the strap. If concerns persist regarding the potential for corrosion, alternative support methods such as mini clips or two-hole straps may be considered. These options generally provide better support for EMT, distributing the load more evenly and reducing the likelihood of moisture being trapped between the EMT and the support. Many clips and straps come in various materials, including corrosion-resistant options, making them suitable for outdoor applications. When selecting EMT supports, always consider the environmental conditions, including exposure to moisture, chemicals, and temperature variations. Choose materials and installation methods that will provide long-lasting protection against corrosion and ensure the integrity of the electrical system. Always consult the latest edition of the NEC and local electrical codes for specific requirements and guidelines related to EMT installation and support. Adhering to these codes and best practices will help ensure a safe and reliable electrical system. Understanding the NEC requirements is paramount for ensuring electrical safety and compliance. While the code doesn't explicitly forbid one-hole straps for exterior EMT, it emphasizes minimizing corrosion. Here's a more in-depth look. Firstly, the NEC Section 110.12 addresses mechanical execution of work. It states that electrical equipment shall be installed in a neat and workmanlike manner. This includes ensuring that supports for EMT are installed properly and securely. Secondly, Section 300.6 covers protection against corrosion. It requires that metal raceways, including EMT, be protected against corrosion, both internally and externally. This section is critical when considering the use of one-hole straps in exterior applications. Thirdly, when using one-hole straps, the material of the strap becomes significant. Using galvanized steel straps with galvanized EMT can provide some level of corrosion resistance due to the sacrificial nature of the zinc coating. However, in harsh environments, even galvanized steel can corrode over time. Stainless steel or aluminum straps offer superior corrosion resistance and are often preferred for outdoor installations. Fourthly, proper installation techniques play a vital role in preventing corrosion. Ensure that the EMT is properly cleaned and free of any debris before installing the straps. Applying a corrosion-inhibiting compound between the strap and the EMT can further enhance protection. Fifthly, consider using a sealant or caulk around the edges of the strap to prevent water from entering between the strap and the EMT. This is particularly important in areas with frequent rainfall or high humidity. Sixthly, regular inspections of the EMT and its supports are essential for identifying any signs of corrosion early on. If corrosion is detected, take immediate action to address the issue, such as replacing the corroded straps or applying a protective coating to the EMT. Seventhly, when using mini clips or straps as alternatives to one-hole straps, ensure that they are properly sized for the EMT being supported. The clips or straps should provide adequate support without causing damage to the EMT. Eighthly, consider using straps with a rubber or plastic coating to provide an extra layer of protection against corrosion. These coated straps can also help to reduce vibration and noise. Ninthly, in some cases, it may be necessary to use a combination of different support methods to achieve the desired level of corrosion protection. For example, one-hole straps may be used in conjunction with conduit hangers or clamps to provide additional support and stability. 10thly, always consult with a qualified electrical inspector or engineer to ensure that the EMT installation complies with all applicable codes and standards. They can provide valuable guidance on selecting the appropriate support methods and materials for specific applications. The NEC doesn't explicitly ban one-hole straps, but its emphasis on minimizing corrosion means careful material selection and installation are crucial. Consider the environment, use corrosion-resistant materials, and implement proper sealing techniques to ensure a long-lasting and safe EMT installation. Remember to consult local codes and a qualified professional for specific guidance. Let's delve deeper into the specifics of EMT installation and corrosion prevention. Firstly, the National Electrical Code, specifically Article 358, covers the requirements for electrical metallic tubing, or EMT. This article outlines the permitted uses, installation methods, and support requirements for EMT. Secondly, Section 358.12 details the uses not permitted for EMT. While it doesn't prohibit the use of one-hole straps, it does state that EMT cannot be used where subject to severe physical damage unless protected. Thirdly, Section 358.30 addresses securing and supporting EMT. It requires that EMT be securely fastened in place at intervals not exceeding 10 feet and within 3 feet of each outlet box, junction box, cabinet, fitting, or termination. Fourthly, the type of support used must be suitable for the application and the environment. In corrosive environments, as previously mentioned, corrosion-resistant materials are essential. Fifthly, when installing EMT in wet locations, such as outdoors, it's crucial to use fittings and supports that are listed for wet locations. These fittings and supports are designed to prevent water from entering the EMT system and causing corrosion. Sixthly, consider using compression-type fittings for EMT connections in wet locations. Compression fittings provide a watertight seal that helps to prevent water from entering the EMT. Seventhly, when cutting EMT, be sure to ream the cut ends to remove any burrs or sharp edges. These burrs can damage the conductors and create a point of corrosion. Eighthly, after reaming the EMT, apply a corrosion-inhibiting compound to the cut ends to protect them from rust and corrosion. Ninthly, when installing EMT in concrete, be sure to protect it from direct contact with the concrete. Concrete can be corrosive to EMT, so it's important to use a protective coating or sleeve. Tenthly, regular maintenance and inspection of the EMT system are essential for identifying and addressing any potential corrosion problems. Check for signs of rust, corrosion, or damage to the EMT fittings and supports. 11thly, if corrosion is detected, take immediate action to repair or replace the affected components. Ignoring corrosion can lead to more serious problems, such as electrical shorts, ground faults, and even fires. 12thly, when replacing corroded EMT, consider using a different type of raceway, such as rigid metal conduit, or RMC, or rigid polyvinyl chloride conduit, or PVC, which may be more suitable for the environment. 13thly, RMC is a heavier gauge conduit that provides excellent protection against physical damage and corrosion. PVC is a non-metallic conduit that is resistant to corrosion from moisture, chemicals, and other environmental factors. 14thly, when using PVC conduit, be sure to use fittings and supports that are specifically designed for PVC. PVC fittings and supports are typically made of PVC or other non-corrosive materials. 15thly, in some cases, it may be necessary to use a combination of different types of raceways to achieve the desired level of protection. For example, RMC may be used for underground runs, while EMT is used for above-ground runs. 16thly, always consult with a qualified electrical inspector or engineer to ensure that the EMT installation complies with all applicable codes and standards. They can provide valuable guidance on selecting the appropriate raceway system and installation methods for specific applications. 17thly, remember that the NEC is a minimum standard, and it may be necessary to exceed the NEC requirements in certain situations to ensure the safety and reliability of the electrical system. 18thly, consider the long-term cost of the EMT installation when selecting materials and methods. While corrosion-resistant materials and proper installation techniques may cost more upfront, they can save money in the long run by reducing the need for repairs and replacements. 19thly, be aware of the potential for galvanic corrosion when using dissimilar metals in the EMT system. Galvanic corrosion occurs when two different metals are in contact with each other in the presence of an electrolyte such as water. 20thly, to prevent galvanic corrosion, use compatible metals for all components of the EMT system, or use a dielectric fitting to isolate the dissimilar metals. In summary, while the NEC doesn't specifically prohibit the use of one-hole straps for exterior EMT, it's crucial to consider the potential for corrosion and take appropriate measures to prevent it. This includes using corrosion-resistant materials, proper installation techniques, and regular maintenance and inspection. Always consult with a qualified electrical inspector or engineer to ensure that the EMT installation complies with all applicable codes and standards.